Part 1, the lupus sex bias, a biological whodunit. Now, systemic lupus erythematosus mainly affects women of childbearing age, presenting this striking sexual dimorphism that scientists have argued about for years. Because it typically hits during those peak reproductive years, it immediately raises some serious suspicions about the role of the female body's natural physiological environment. So, the really crucial point here is that researchers have historically been totally torn between two leading culprits. On one side, you've got the hormonal theory. This one asks, is it the estrogen circulating in the body that's driving these overactive immune responses? Or, on the flip side, you have the chromosomal theory, which asks, is it actually just the presence of double X chromosomes at the genetic level, completely regardless of the person's physical sex phenotype? Let's look at part 2, suspect 1, the hormonal theory. We're going to examine how sex hormones, like estrogen, actively manipulate the body's immune system. Because, hormones aren't just for reproduction. They're incredibly powerful chemical messengers that interface directly with our cellular defenses. Now, estrogen doesn't just do all this by itself, right? It relies on specific receptors, like estrogen receptor-alpha, or ER-alpha, and its counterpart, ER-beta, to actually get its message across. You can think of these receptors as molecular switches located right inside our immune cells, particularly T cells and dendritic cells. So when estrogen binds to them, it basically flips the switch, permanently altering how these immune cells behave, how they differentiate, and how aggressively they respond to threats. Moving to part 3, immune alarms and estrogen. It is absolutely fascinating to trace estrogen's exact path of destruction when it comes to lupus pathogenesis. We're not just talking about some vague general increase in inflammation here. It's a highly specific, locked-in chain of events. Just watch how this creates a literal cellular domino effect. First up, estrogen binds to ER-alpha. Second, that binding forces specific immune sentinels, these are called plasmacytoid dendritic cells, or PDCs, to mature and activate. Third, this activation massively upregulates toll-like receptors 7 and 9. Now, these TLRs are essentially your immune system's alarm sensors, normally just meant to detect viral RNA and DNA. But in step 4, because these sensors are dialed way up, they trigger a completely excessive production of Type I interferons and autoantibodies. Suddenly, the body starts actively attacking its own nuclear elements. And we actually know this hormone pathway is guilty, for sure, because we can test it. When researchers took lupus-prone mice and genetically knocked out the ER-alpha gene, basically snapping off that molecular switch, they saw a dramatic plunge in inflammatory markers like IL-6. It physically broke the chain and just halted the progression of the disease. This strongly suggests that estrogen is actively fueling the fire. Part 4, suspect 2, the chromosomal theory. But, as you might guess, estrogen doesn't explain the whole picture. For instance, prepubescent girls and postmenopausal women still get lupus. And that brings us to our second suspect, the X chromosome itself. So, biological females carry 2 X chromosomes. Normally, to prevent a toxic double dose of genetic products, cells go through a process called X chromosome inactivation, totally silencing one of them. However, our sources detail this wild phenomenon called X chromosome inactivation escape. Basically, certain genes on that supposedly dormant second X chromosome manage to totally evade the lockdown. This essentially gives the female body a biological backup generator for certain proteins that literally never turns off. And the sources show that these specific X-linked genes are vastly overexpressed in female autoimmunity because of this exact escape mechanism. Look at the top of the list there, TLR7. Remember our immune alarm sensor from the hormone pathway just a minute ago? Since it sits directly on the X chromosome, women who experience inactivation escape are getting a double dose of this exact sensor, right alongside other key immune regulators like KDM6A, CXORF21, and IRAK1. Which brings us to part 5, the genetic dosage effect. To truly prove this chromosome theory, scientists needed to completely untangle the X chromosome from female hormones. They did this by studying rare genetic karyotypes to see if the raw number of X chromosomes drove the risk, entirely regardless of the person's sex phenotype. This data right here is the smoking gun. Look at the third row. Individuals with a 47XXY karyotype, which is known as Klinefelter syndrome. These are phenotypic males, meaning they do not have female estrogen levels, but they do have an extra X chromosome, and their risk for lupus jumps by 14-fold compared to baseline males. And females with 3X chromosomes, that jumps to a 25-fold increase. This tells researchers loud and clear that genetic dosage, literally just having more X chromosomes, is a massive, totally independent driver of the disease. Finally, part 6, 2 theories, 1 disease. Okay, moment of truth. Which theory is actually correct? Is it the estrogen or is it the extra X chromosome? Well, as it turns out in this medical mystery, it's not an either-or scenario. They are accomplices, and they're working closely together.
When you bring it all together, you see the perfect autoimmune storm. First, the X chromosome lays the genetic groundwork. Through inactivation escape, it supplies the body with an extra dose of TLR7 immune sensors, so the baseline sensitivity is already way too high. Then estrogen enters the chat, binds to ER-alpha, and aggressively upregulates the signaling of those exact same sensors. You've got a double dose of the alarm bells, and estrogen is the hormone actively ringing them. This combined force is what drives the fatal production of autoantibodies that end up attacking the body's own DNA and RNA.
So what's the big takeaway for us today? By decoding this incredibly complex biological tag team between our chromosomes and hormones, we can fundamentally change how we approach clinical care. We're talking about developing highly targeted treatments that can actually block specific pathways, like TLR7 or ER-alpha. We can also make critical healthcare decisions, like managing high-risk pregnancies or safely prescribing hormone replacement therapies, far safer for these patients. Unraveling the why behind the lupus sex bias isn't just some academic exercise, it is quite literally the key to saving lives. But it does leave us with a really critical question moving forward. As we continue to map the exact intersection of our genes and hormones, just how close are we to finally outsmarting autoimmunity altogether?